Alright. So, 3.6, they want to know degrees of freedom within. Degrees of freedom within, again, is n, well, capital N minus k. So, remember that k is how many treatments you have, or levels, or whatever you want to call them. It's just how many groups you're experimenting on. So, you have 2. Wonder what k equals. So that'll find you degrees of freedom within, and then they want you to find degrees of freedom between, which is k minus 1. Since you already found k, you just subtract 1 from it, and you get. I'm not gonna tell you. It's a crazy answer. And so then they want you to find your ms within, which I like ms within and ms between because it's pretty simple to remember the formula. It's sum of squares between, or sorry, we're doing within. Sum of squares within divided by degrees of freedom within. And that's the answer. So, I mean, it's nice because you've already found everything. Your ms between is your sum of squares between divided by your degrees of freedom between. That's what it is. And then they want you to find your f value. Yay! F value is your ms between divided by your ms within. And so that will equal a number. And then, if you remember what your t-score was, it's t squared. Oh, that's cool. That's cool. We are almost done. 4 and 5. You know, we're making progress. Let's see. They want you to find. Excuse me. Again, in 4.1, they want you to find your pooled variance. So remember, pooled variance is SS1 plus SS2 over the degrees of freedom 1 plus degrees of freedom 2. Then on the next problem, they will want you to find T. And T, again, is... Actually, this time I did M1 minus M2. It's just, you just kind of want to have a positive number. If you have a negative one, you just turn it into a positive. So I just subtract the bigger mean from the smaller mean over the square root, the entire square root, like the square root of all of this, of your pooled variance over N1 plus pooled variance over N2. And that'll give you your t-score. So then, they're going to ask for your sum of squares total. Sum of squares total, again, is the sum of x squared minus g squared over capital N. And they give you all of that information, so you should be able to figure that out pretty quickly. Sum of squares within is the sum of the sum of squares of conditions, which, again, just add up the two sum of squares they give you, and that is your sum of squares within. Then, to find degrees of... to find sum of squares between, you can either subtract sum of squares within from sum of squares total, or do the equation I gave you, just for the sake of not repeating myself. Whatever. You can just subtract it. No big deal. You should have the right answers. Then they're going to ask for degrees of freedom within, which is capital N minus K. And again, K is the number of groups you're experimenting on. Actually, that's not true. It's true in independent measures, but it's actually like the conditions, the different levels and conditions. So, treatment 1, treatment 2. If it's a repeated measures test, it's like how many times you checked up on them. So, like, if it, Anyway, that's K. Degrees of freedom within, capital N minus K. Degrees of freedom between is K minus 1.
Hey, I know this one.
And then...
Hey, Ben.
Oh, hey.
Sorry.
No, it's fine. And then...
Can you not hear anything? Give me a second.
Degrees of freedom with... Oh, degrees of freedom between is K minus 1. And then...
Dude, nice one.
Degrees of total degrees of... I don't know if they asked you for that. If they do ask for degrees of freedom total, it's those 2 degrees of freedom you found added together. And then they're going to ask you for your standard mean deviation within, which is just your sum of squares within divided by your degrees of freedom within, and then your standard deviation, your standard mean deviation between is just sum of squares between divided by degrees of freedom between. And then they're going to ask you to calculate your F, which is just your MS between over your MS within, because I don't even know what that really stands for. And that's the end of number 4. All right, number 5. It is just, it's a table, and there's a lot of stuff to do. But just go ahead, start with degrees of freedom. Between, remember, is k minus 1. Within is capital N minus k, and then total is just those two added together. And then to find your sum of squares, you can actually just do what we've been doing all the entire time. I'm going to go ahead and just like give you equations and stuff. I actually found each of those sum of squares using the formulas because I didn't want to be like super inaccurate. I don't know exactly what he wanted us to do. If you do it the way that he set it up, you would solve for your sum of squares total first. So you would say, you would take the sum of x squared minus g squared over capital N, which all that information is there, and that would equal your total. And then you would calculate your within, so that would be your sum of conditions. So each of those little sum of squares, you just add those up, and that's your sum of squares within. And then between, you would just subtract your within from your total. I did the equation, which it's like a point something, very small difference. If you're just pressed for time, go ahead and subtract them. If you want to do the equation, it is the sum of t squared over n minus g squared over n. So each t squared divided by their respective n, which in this case all of the little n's are the same. They're all 6. Anyway, that'll figure out your sum of squares. And then you'll want to find your MS within and between. So to find MS between, you would take your sum of squares between and divide it by your degrees of freedom between. To find your MS within, you would take your sum of squares within and your degrees of freedom within. Or sum of squares within divided by degrees of freedom within. So then you'll have all of that, and then you just need to find your F, which is your MS between divided by your MS within. My F was freaking big. It was a big F number. So, you know, if you get like a normal one, like a, I don't know. I say freaking huge, it's like 2 digits. Anyway, and then I calculated the F critical. So remember that you're using, I don't know if I explained this on the first one. If you read the table, it'll tell you that the normal font is when your alpha equals 0.05, and the bold font is for 0.2 or something. So anyway, you're just going to go back to that table, the F distribution table, and you're going to go in the left column, use your degrees of freedom within on the left column, and your degrees of freedom between on the top, and you'll just find your F critical. So remember, if your F is bigger than your F critical, then you're going to reject the null hypothesis, and there will be a significant difference because that's the way life is. So then they're going to want you to calculate your eta I think, squared, which again is sum of squares within over sum of squares total. I got pretty good. I mean, like, it's like, yeah, it's a decimal. And then they want you to calculate Tukey Tukey. Tukey Tukey is the, it's Q, which I will explain in a second. Q times the square root of MS within over N. So Q, you have to go to another table, which is called the studentized something or other. It's underneath the F distribution table, and it's like the studentized number doohickey thingy. So anyway, you'll go to that table, and you will use your degrees of freedom within on the left and K on the top. So it'll say like something like air or whatever. It's just degrees of freedom within. Don't worry too much about it. It's just the same one that you've been using, and then K on the top, and then you'll calculate. You'll just go down the columns. You'll find your Q. So that's what Q equals. So then you're going to take that number, multiply it by the square root of your ms within over n, and that'll equal your tuki number, or Q. Huh. What if I did that wrong? If that's right, then you just look at the mean differences. So basically you subtract each mean from each mean, and see what the difference is. And if it's bigger than your tuki number, then it's significant, and if it's smaller, then it's not significant. Now that I look at it, it says Q equals, so like I'm kind of worried, but I'm pretty sure I did it right, or at least as right as I could from the notes I have. It looks right. Yeah, that's probably right. If that freaks you out, you can read the book. Like, that'll help. So yeah, just remember that there's a quiz on Monday, and I will see you then.